Climate change refers to long-term shifts in temperatures and weather patterns. Such shifts can be natural, due to changes in the sun's activity or large volcanic eruptions. But since the 1800s, human activities have been the main driver of climate change, primarily due to the burning of fossil fuels like coal, oil, and gas. Burning fossil fuels generates greenhouse gas emissions that act like a blanket wrapped around the Earth, trapping the sun's heat and raising temperatures. The main greenhouse gases that are causing climate change include carbon dioxide and methane. These come from using gasoline for driving a car or coal for heating a building, for example. Clearing land and cutting down forests can also release carbon dioxide. Agriculture, oil, and gas operations are major sources of methane emissions. Energy, industry, transport, buildings, agriculture, and land use are among the main sectors causing greenhouse gases. Climate scientists have showed that humans are responsible for virtually all global heating over the last 200 years. Human activities like the ones mentioned above are causing greenhouse gases that are warming the world faster than at any time in at least the last 2,000 years. The average temperature of the Earth's surface is now about 1.2 degrees Celsius warmer than it was in the late 1800s, before the Industrial Revolution, and warmer than at any time in the last 100,000 years. The last decade, 2011 to 2020, was the warmest on record, and each of the last 4 decades has been warmer than any previous decade since 1850. Many people think climate change mainly means warmer temperatures. But temperature rise is only the beginning of the story. Because the Earth is a system, where everything is connected, changes in one area can influence changes in all others. The consequences of climate change now include, among others, intense droughts, water scarcity, severe fires, rising sea levels, flooding, melting polar ice, catastrophic storms and declining biodiversity. Climate change can affect our health, ability to grow food, housing, safety, and work. Some of us are already more vulnerable to climate impacts, such as people living in small island nations and other developing countries. Conditions like sea level rise and saltwater intrusion have advanced to the point where whole communities have had to relocate, and protracted droughts are putting people at risk of famine. In the future, the number of people displaced by weather-related events is expected to rise. Every increase in global warming matters. In a series of UN reports, thousands of scientists and government reviewers agreed that limiting global temperature rise to no more than 1.5 degrees Celsius would help us avoid the worst climate impacts and maintain a livable climate. Yet policies currently in place point to a 3 degrees Celsius temperature rise by the end of the century. The emissions that cause climate change come from every part of the world and affect everyone, but some countries produce much more than others. The 7 biggest emitters alone, China, the United States of America, India, the European Union, Indonesia, the Russian Federation, and Brazil, accounted for about half of all global greenhouse gas emissions in 2020. Everyone must take climate action, but people and countries creating more of the problem have a greater responsibility to act first. Many climate change solutions can deliver economic benefits while improving our lives and protecting the environment. We also have global frameworks and agreements to guide progress, such as the Sustainable Development Goals, the UN Framework Convention on Climate Change and the Paris Agreement. 3 broad categories of action are, cutting emissions, adapting to climate impacts and financing required adjustments. Switching energy systems from fossil fuels to renewables like solar or wind will reduce the emissions driving climate change. But we have to act now. While a growing number of countries is committing to net zero emissions by 2050, emissions must be cut in half by 2030 to keep warming below 1.5 degrees Celsius. Achieving this means huge declines in the use of coal, oil, and gas. Over 2/3 of today's proven reserves of fossil fuels need to be kept in the ground by 2050 in order to prevent catastrophic levels of climate change. Adapting to climate consequences protects people, homes, businesses, livelihoods, infrastructure, and natural ecosystems. It covers current impacts and those likely in the future. Adaptation will be required everywhere, but must be prioritized now for the most vulnerable people with the fewest resources to cope with climate hazards. The rate of return can be high. Early warning systems for disasters, for instance, save lives and property, and can deliver benefits up to 10 times the initial cost. Climate action requires significant financial investments by governments and businesses. But climate inaction is vastly more expensive. One critical step is for industrialized countries to fulfill their commitment to provide $100 billion a year to developing countries so they can adapt and move towards greener economies. In common usage, climate change describes global warming, the ongoing increase in global average temperature and its effects on Earth's climate system. Climate change in a broader sense also includes previous long-term changes to Earth's climate. The current rise in global average temperature is primarily caused by humans burning fossil fuels since the Industrial Revolution. Fossil fuel use, deforestation, and some agricultural and industrial practices add to greenhouse gases. These gases absorb some of the heat that the Earth radiates after it warms from sunlight, warming the lower atmosphere. Carbon dioxide, the primary greenhouse gas driving global warming, has grown by about 50% and is at levels unseen for millions of years. Climate change has an increasingly large impact on the environment. Deserts are expanding, while heat waves and wildfires are becoming more common. Amplified warming in the Arctic has contributed to thawing permafrost, retreat of glaciers and sea ice decline. Higher temperatures are also causing more intense storms, droughts, and other weather extremes. Rapid environmental change in mountains, coral reefs, and the Arctic is forcing many species to relocate or become extinct. 11. Even if efforts to minimize future warming are successful, some effects will continue for centuries. These include ocean heating, ocean acidification, and sea level rise. Climate change threatens people with increased flooding, extreme heat, increased food and water scarcity, more disease, and economic loss. Human migration and conflict can also be a result. The World Health Organization, WHO, calls climate change one of the biggest threats to global health in the 21st century. Societies and ecosystems will experience more severe risks without warming. Adapting through efforts like flood control measures or drought-resistant crops partially reduces climate change risks, although some limits to adaptation have already been reached. Poorer communities are responsible for a small share of global emissions, yet have the least ability to adapt and are most vulnerable to climate change. Many climate change impacts have been felt in recent years, with 2023 the warmest on record at plus 1.48 degrees C, 2.66 degrees Fahrenheit, since regular tracking began in 1850. Additional warming will increase these impacts and can trigger tipping points, such as melting all of the Greenland ice sheet. Under the 2015 Paris Agreement, nations collectively agreed to keep warming well under 2 degrees C. However, with pledges made under the agreement, global warming would still reach about 2.7 degrees Celsius, 4.9 degrees Fahrenheit by the end of the century. Limiting warming to 1.5 degrees Celsius would require having emissions by 2030 and achieving net zero emissions by 2050. Fossil fuel use can be phased out by conserving energy and switching to energy sources that do not produce significant carbon pollution. These energy sources include wind, solar, hydro, and nuclear power. 2930 Cleanly generated electricity can replace fossil fuels for powering transportation, heating buildings, and running industrial processes. Carbon can also be removed from the atmosphere, for instance by increasing forest cover and farming with methods that capture carbon in soil. Before the 1980s it was unclear whether the warming effect of increased greenhouse gases was stronger than the cooling effect of airborne particulates in air pollution. Scientists used the term inadvertent climate modification to refer to human impacts on the climate at this time. In the 1980s, the terms global warming and climate change became more common, often being used interchangeably. Scientifically, global warming refers only to increased surface warming, while climate change describes both global warming and its effects on Earth's climate system, such as precipitation changes. Climate change can also be used more broadly to include changes to the climate that have happened throughout Earth's history. Global warming, used as early as 1975-39, became the more popular term after NASA climate scientist James Hansen used it in his 1988 testimony in the U.S. Senate. Since the 2000s, climate change has increased usage. Various scientists, politicians, and media may use the terms climate crisis or climate emergency to talk about climate change, and may use the term global heating instead of global warming. The Earth's climate is changing, and the global climate is projected to continue to change over the century and beyond. The magnitude of climate change beyond the next few decades will depend primarily on the amount of greenhouse, heat-trapping, gases emitted globally and on the remaining uncertainty in the sensitivity of the Earth's climate to those emissions. With significant reductions in the emissions of greenhouse gases, GHGs, global annual average temperature rise could be limited to 2 degrees Celsius or less. However, without major reductions in these emissions, the increase in annual average global temperatures, relative to pre-industrial times, could reach 5 degrees Celsius or more by the end of this century. The global climate continues to change rapidly compared to the pace of the natural variations in climate that have occurred throughout Earth's history. Trends in globally average temperature, sea level rise, upper ocean heat content, land-based ice melt, Arctic sea ice, depth of seasonal permafrost thaw, and other climate variables provide consistent evidence of a warming planet. These observed trends are robust and confirmed by multiple, independent research groups around the world. Observed changes over the 20th century include increases in global air and ocean temperature, rising global sea levels, long-term sustained widespread reduction of snow and ice cover, and changes in atmospheric and ocean circulation, as well as regional weather patterns, which influence seasonal rainfall conditions. These changes are caused by extra heat in the climate system due to the addition of greenhouse gases to the atmosphere. These additional greenhouse gases are primarily input by human activities such as the burning of fossil fuels, coal, oil, and natural gas, deforestation, agriculture, and land use changes. These activities increase the amount of heat-trapping greenhouse gases in the atmosphere. The pattern of observed changes in the climate system is consistent with an increased greenhouse effect. Other climatic influences such as volcanoes, the sun, and natural variability cannot alone explain the timing and extent of the observed changes. Climate refers to the long-term regional or global average of temperature, humidity, and rainfall patterns over seasons, years or decades. While the weather can change in just a few hours, climate changes over longer time frames. Climate change is the significant variation of average weather conditions becoming, for example, warmer, wetter, or drier over several decades or longer. It is the longer-term trend that differentiates climate change from natural weather variability. Human activity leads to change in the atmospheric composition either directly, via emissions of gases or particles, or indirectly, via atmospheric chemistry. Anthropogenic emissions have driven the changes in WMGHG concentrations during the industrial era. Radiative forcing, RF, is a measure of the net change in the energy balance of the Earth system in response to some external perturbation. Positive RF leads to a warming and negative RF to a cooling. The RF concept is valuable for comparing the influence on global mean surface temperature of most individual agents affecting the Earth's radiation balance. Thank you for watching this video.